That's why they're like,
Okay,
Context.
so here's what you've got. Hopefully the humidity isn't too high today where you can still charge the balloons. That's always a problem with electricity. And it was interesting watching yesterday as you all were trying, or on Friday when you had to charge balloons, and you were trying to measure them. So why did that become frustrating when you tried to measure them? Yeah, you became so easily a part of the system. Okay? You guys look, oh, it's just holding up a meter stick between the balloons. Well, guess what? The meter sticks became attracted to you. So then it's like, well, how do you isolate this? So now this is dealing with gravitational. This is dealing with electrostatic force. So even if you look at what Henry Cavendish did, so Henry Cavendish, remember, he was the first one like to weigh the Earth. He found the universal gravitational constant. So he did a similar type of thing what you all did. And he had the torsion wire, and he had like large weights on each end, and then he had other ones near. So Cavendish, even on a gravitational force, which is much weaker than your electrostatic force, Cavendish, his equipment was so sensitive that he actually had a room built onto his house. He literally was a separate room. He didn't want to be in that room because he was afraid his equipment was so sensitive that his mass might alter the result. So that's why he had a separate room built on his house. So now imagine what you all are trying to do with this electrostatic force. That is always the frustration of dealing with electrostatic forces, is because you so easily become part of the system and you alter those observations. So here's, as you go through the write-up, you can have pictures, you can, if you want to do that. Keep in mind you're only going to hand in one write-up per group, which is due tomorrow, okay? So, but you have the, as soon as I get done talking, you're going to have the rest of the day to work on this, okay? But here needs to be your mindset. When you write this procedure, you don't have to write it so like a freshman could follow it, but you do need to say, hey, here's what we're going to measure. Whether you measure the circumference of the balloon, the diameter of the balloon, what do you do with that number? Where is your data table? Okay, you're going to have two different balloons. Which one are you calling mass 1 and which one are you calling mass 2? When you find the mass of the balloons, are you finding those masses before you inflate the balloon or after you inflate the balloon? If you tell them, oh, equate or inflate the balloons to, you just say blow up the balloons, well, I don't know how big that is. So the idea being, and this is important in terms of how science is done, I should be able to take any of your write-ups and completely replicate your results. Okay? That's the mark of any good scientific explanation. Is to get somebody else who has a baseline knowledge of what you're doing, get your results. So here's the vague part if you say, oh, you just blow up the balloons. Well, if I only blow up the balloon to this size versus you blow it up to this size, we're going to get completely different results. And if you just say, oh, take a piece of string and drape it over the hook, and if that's all you tell me, like, I don't know how long a piece of string is. Okay? Do I make it this long? Do I make it this long? I don't know. Okay? So now you don't have to say measure it 50.0513. Okay, there's also a limit to how, of that as well. So most of your grade is going to be based upon your calculations. How do you determine, and this is the whole key to this, the gravitational force between the two balloons? Remember, that's going to be F equaling big G M1 M2 over distance squared. Now, to make this simple, you can treat the two balloons as a point mass. Okay? Technically, all of the little particles that make up each balloon are attracted to each individual, all the particles that make up the other balloon. Okay? We're not going to worry about that. Treat it as a point mass. Going, here's a point here on their centers. What's the distance between them? The tricky part of this is that you need the actual mass, okay? So you put the scales on, you put the balloons on the scale. You got numbers in grams. Is the question being, is that the actual mass of the balloons? I'm just telling you, that's the question, okay? And if you say no, it's not, then you show me how you got the actual mass, okay? Yes.
Just to clarify, buoyancy is not on the test.
No,
Is that where we use the buoyancy?
I don't know.
Yes.
He knows, but he's not gonna.
Oh, I do. I'm not
The
gonna.
bold-faced lie, as you say.
Oh, that's a bold-faced line.
Wrote the test, by the way.
Okay? Buoyancy will not be on the test, okay?
You should put on the test for his point.
But, so here's what's gonna happen. I'm gonna make a chart on the back, whiteboard back there. And when your group gets done calculating the number of electrons, the charge, all of those things, I want you to fill that in. So that way we can compare groups and see if everybody's kind of getting about the same thing. Now, if you're, if one group gets like 10 to the 13th electrons, I'm just making up a number, and you get 10 to like the 7th, ooh, somebody's way off, okay? Right? Somebody's way off. So that's the reason that we're doing it. It's almost like a peer review process. Everybody's going to throw their data out there to see, and you're going to compare your data to everybody else's, okay? There's going to be some variance on it. Now, here's the other thing that's important in terms of what you can assume. For the sake of simplicity, you can assume that each balloon is equally charged, okay? Because if not, that gets real weird, because then you'd have to know the total charge on, and then you'd have to work it as a quadratic, and that's just going to get real weird real fast, okay? So just treat the balloons as point masses in terms of the calculation of this gravitational force, and assume that each balloon has an equal amount of charge, okay? So I'm going to tell you right now, the tricky part is getting a precise measurement of like your lengths and your angles. That's the trickiest part of this lab. How do you get that data? And you want to explain that. If you just say, oh, measure the angle. Well, you better tell me how to measure that angle without me being a part of that system, okay? That's one of the things you want to lay out. You've got to tell me how I do that measurement, and I'm not part of that system, because that's tough. What? Welcome to science. Welcome to science. Okay, I'm done. You have the rest of the time.
Was this the chaotic laboratory?